Hey everybody, so let's take a look at using the limit definition of the derivative to find the value of a derivative for a given function. So you can see here I have f of x is equal to x squared minus 3x, and I am asked to find f prime of 2. You may know some other little tricks to find this value, but I'm asking you specifically to use the limit definition of the derivative, which means you must use the limit definition of the derivative to do this. So let's use this limit definition. So the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now one thing you might notice or might not notice, because it's not totally obvious, is that this denominator is really x plus h minus x, which if you just simplifies to the h. But the reason I've written this as two separate items in this example is I want you to just notice that this is f of b minus f of a over b minus a for the interval that goes from x to x plus h. So this limit definition is really what we get if we are finding the average rate of change over this interval, and we're simply letting the width of that interval, that is the difference between x plus h and x, approach 0. And if we simplify this expression, which is the width of that interval, that just gives us h approaching 0. So that's what we're trying to do. Let's evaluate this limit. I know I am likely going to forget writing limit as h approaches 0 every single time. You need to include this every time for using the limit definition. Let's do this the right way. So limit as h approaches 0 of f of x plus h minus f of x over h. Let's evaluate f of x plus h and also f of x just so that we do this right. We don't want to lose any terms. So f of x plus h is going to be, using the definition for f of x up here, it's going to be x plus h squared minus 3 times the quantity x plus h. And f of x is just going to be x squared minus 3x, exactly the same as our definition of the function. So let's then calculate f of x plus h minus f of x, because that ultimately is what's going to go in this top portion of our limit. So f of x plus h minus f of x is going to be the quantity of x plus h squared minus 3 times x plus h minus x squared minus 3x. Now, notice my use of parentheses here. If you're going to make a mistake in the beginning, this is what it's going to be. You are subtracting the entire f of x, and f of x is this entire expression of x squared minus 3x. So when we subtract this, we must make sure that we are subtracting the entire f of x. It's very easy to miss this final negative sign right there and not change it to be a positive when you distribute the negative sign to it. So let's expand this. So x squared plus 2xh plus h squared minus 3x minus 3h minus x squared, and here's where that negative sign comes in. This becomes plus 3x. And you'll notice a couple things will now disappear. We have x squared minus x squared, so that's going to go bye-bye. We have negative 3x, and we have positive 3x that are also going to add up to 0. So let's now go back to our limit definition. This is the limit as h approaches 0 of f of x plus h minus f of x. So let's get the result after we've simplified this. So this is now 2xh plus h squared minus 3h, and that's all over h. Okay, now at this stage, we might think about evaluating this limit. Well, if we substitute h equals 0 into this, the result we're going to get, because everything has an h, we get 0 divided by a 0, which is our warning sign that tells us we need to do something else. But we can also, at this step, notice that there is a way to factor out an h from the numerator. So we get h on the outside, and on the inside, 2x plus h minus 3. Dividing that all by h, and sure enough, now we have an h in the numerator and an h in the denominator, so we can simplify this a little bit to become limit as h approaches 0 of 2x plus h minus 3. Okay, and that limit we can just take directly by substituting, because if we do that, we don't have any indeterminate form. We just have 2x plus 0, because that's the limit there, minus 3, and let's just erase that plus 0 and leave us with 2x minus 3. Now, this right here is actually the derivative function f prime of x, and that's equal to 2x minus 3. So this is the limit definition of the derivative that I came up with up here. This expression actually gets you f prime of x, the derivative function, so that we can find what the instantaneous rate of change is for any value of x. But this question is asking us to find f prime of 2. So let's evaluate this. F prime of 2 is going to be just this result evaluated at 2. So 2 times 2 minus 3, which gives us 1. So that is one form of using the limit definition of the derivative to evaluate the derivative at a particular x value.